This video depicts servicing live equipment containing a cathode ray tube. The equipment contains potentially lethal voltages. These voltages may persist even after AC power is removed. A CRT in operation, particularly an older one such as is present in this unit, may emit harmful amounts of X-ray radiation when in operation. A CRT also contains a high vacuum and may implode violently if broken. Please use appropriate personal protective equipment and do not attempt to service units like this if you are not trained to deal with the hazards.
Hi, I'm Kevin. Welcome to my cave. I thought I'd have a change of pace with this video. You see, I have an idea for a silly project that I think will be kind of fun. I don't want to say what it is, because that would spoil the punchline, but it will need an analog oscilloscope. And well, I own an analog scope. It's this behemoth. What we're dealing with here is an Alpha November slant bar Uniform Sierra Mike -281 Charlie oscilloscope. I understand that in the 1970s, it was a pretty standard oscilloscope that virtually any military electronic service tech would be familiar with. It announces that it was procured by the U.S. Army CERCOM from Tektronix in Beaverton, Oregon. So it was probably a pretty good scope when it was built, and probably the taxpayers paid a lot of money for it. Under contract Delta Alpha Alpha Bravo 07-78-Charlie 2989. It's a portable unit, at least according to the military definition of the term. There's a handle on it. It still has a military asset tag on the back of the unit that asserts that it belonged once to the Naval Electronic System Command and was procured on a 1973 contract. So I presume that means that this scope is about 52 years old. It feels as if this sheet metal case might have been designed to take small arms fire. But let's have a look at what's inside. Already I've got the first problem. This faceplate is stuck. Real problem getting it loose. There it goes. Oh, and I see why that is. This weather stripping material, or whatever it is pretty badly deteriorated. It's stiff, and it's no longer stuck to that cover. So I'm going to have to look at replacing that. But let's set that aside for the moment and have a look at what the scope itself. It's designed like a lot of tech scopes of the period. It's got a mainframe unit on the top that has a CRT display, including a clever little fixture for a Polaroid camera, and the controls for beam intensity and focus, graticule illumination, a button for a beam finder, and a couple of display modes: left channel, alternate, add the channels, chop, right channel, and a trigger source. It's got the power switch, and it's got a calibrator output. Then across the bottom, there are bays for plugins. And what this scope has is two vertical amplifiers, so it's a dual trace scope. And each of the vertical amplifiers has got its scale, its position, its polarity, upright or inverted, its mode, which is basically which scope probe you've got, an X1 or an X10 scope probe, and AC or DC coupling. And then it's got a time base, which has its time per division. It's got a couple of trigger inputs, and it's got a lot of complicated triggering controls that I'm not going to go into in this episode. There's just one minor problem with this scope. It's been sitting in my garage for about 20 years unused. I don't know what kind of shape it's in. Well, there's one way to find out. Since the thing was in good working order when I put it away, I somewhat foolhardily decided to plug it in and give it a quick check out. Wish me luck. Graticule lights up. And I remember the thing always took a while to warm up. But I should be seeing the beam by now. It's there somewhere. Not in the greatest focus. And it's way off to the left and way off at the top. So let me see if I can bring down the vertical position some. Oh wait, that's the horizontal. I'm sorry. Bring the horizontal position down some. Well, I can get it approximately centered. And adjust the vertical position, and there it is. It's trigger level and slope. That's weird. When I change the time per division, that's going vertically. And well, obviously I need to adjust the focus here. Yeah, this should be showing a horizontal line. And it isn't. It looks like, I don't know, maybe... That's just weird. I changed the time base and the beam jumps around all over the place. So I'd say that in the time that this has been put away, there's something gone wrong with the unit. I better take it apart and investigate. The case is in two halves, and each one is held on with half a dozen Suze fasteners. So I should be able to release the 6 fasteners. And then the manual says to lift up on the case and swing it outward. And when I tried to do that, it wasn't budging at all. Eventually, what I wound up doing was taking a little pry bar and spudging all along the edges here, and I was hearing stuff go each time. And unfortunately, I did that off camera. So now I'm able to lift up and swing it out and then slide it out the way the manual says. And what do I find? I find more deteriorated weather stripping, which was thoroughly stuck to the inside of the case. Inside, I'm seeing about what I expected to see. The build quality looks pretty good. The boards look to be in good shape. I'm not seeing any obvious burnt components anywhere inside, although everything is a little bit dusty. Whenever I see weird behavior like the horizontal sweep showing up vertically on the screen, the first thing I suspect is the power supply. So what I'm going to do, I think, is power up this unit very carefully and measure what the power supply is putting out. Conveniently, over here, there's a little wiring harness with all the power supply voltages right beside one another. So that should be a good place to probe. And they're even labeled on the circuit board. So this one here is supposed to be plus 130 volts. Sorry, minus 130 volts. So that's indeed what it is. Next one is supposed to be plus 50. That's pretty accurate. Plus 15. Plus 5. Good. Ground. Yeah, I'll buy that as ground. Minus 15. Oh, minus 13. There's a definite undervolt there. And the way my analog bar on the meter is flickering, I think the regulator also is not regulating. So that's going to be a place to look at. That minus 15 volts on the power supply I think is bad. And finally, minus 50 volts. And again, minus 50 volts looks to be dead on. So I think the first problem, or at least the first electronic problem, we've already seen a couple of mechanical problems, is that the 15-volt power supply, the negative 15-volt power supply, is bad. So I'm going to have to get that out of the case and have a look at it. And that's where I hit the next problem. Off camera, I managed to get out one of the screws that holds it down. But the others, some sailor has really over-tightened. I can see some damage to the slots in just about all of them, and this one it's stripped out entirely. And I just can't get enough purchase on a Phillips to back them out. I've already given them several shots of penetrant, both squirting on the inside and squirting around the screw on the outside, and they are not budging. So I think it's time to break out the impact driver.
Once I had the power supply mostly out, I looked in the manual to see whether there was a parts placement diagram to locate where I might want to probe inside the power supply. I did find a placement diagram, but on the facing page I found this picture, which showed where the proper test points for the power supply are. I'd been probing the wrong location for the positive 130-volt supply. The correct location is on this fuse up here under the handle, and the positive 130 is within spec according to the table in the manual. That's also where I found the trimmer for the negative 50-volt supply, and I got it into spec off camera while I was at it. Now to troubleshoot the negative 15-volt supply. I should give an explanation of the schematic for those of you who've never worked on vintage gear like this. The negative 15-volt supply begins with one of the 4 secondary windings on the power transformer. There's a bridge rectifier generating unregulated positive 26 and negative 26 volt supplies, with energy storage capacitors on those lines, and 4.7K bleeder resistors. The negative 26 volt line comes down to a voltage regulator circuit. It's kind of complicated because it's all built from discrete semiconductors. You couldn't just plug in an LM337 in there, because this scope was built a few years before the 337 was available. When we look at the regulator circuit, though, we can understand it. It's almost the same as the discrete op-amp that we just built over in Transistors 101. And believe it or not, I filmed those videos before I started on this project. To begin with, let's recognize there's a feedback loop in play. Whatever this circuit is putting out will go out to the rest of the instrument, and at a distant point, there's a separate wire coming back with what the voltage is at the remote point. The reason for this is that the wire carrying the power has a non-zero resistance, and it will be carrying the full current of the power supply, so it'll have a small voltage drop. The sense wire will be carrying nearly no current, and so it can accurately sense the 15 volts of the load, so the feedback loop will compensate for the wiring resistance. The sensed voltage comes into a long-tailed pair, whose other input is a negative 15 volt reference derived from the negative 50 volt supply. The pair generates an output voltage proportional to the difference between these voltages, that is, the voltage error at the load. By the way, the huge voltages and correspondingly huge resistors were pretty typical of the devices of the period. The resistors functioned as high-impedance current sources. Transistors were too expensive to squander them on delivering small constant currents. The long-tailed pair feeds a PNP gain stage, just as in the amplifier we built. And the gain stage feeds a Darlington to boost the output current. There doesn't need to be a push-pull stage because a negative supply is only ever pulling. It sinks current and never sources it. There's a 0.1 ohm resistor whose voltage drop will measure the current. A 0.1 volt drop would be a current of 1 ampere. A long-tailed pair is driven from the two sides of this resistor. If the current is too high, the pair begins to sink current from resistor R952, which reduces the negative voltage out of the PNP gain stage, cutting back the output voltage so the target current is never exceeded. There are only a few things that are really likely to be the culprit if this circuit isn't putting out the correct voltage. First is that the filter capacitor hasn't aged gracefully and isn't filtering. Second is that there's something else in the instrument that's drawing an overcurrent, causing the current limiting to drop the voltage. I don't think this is terribly likely, because if it were sucking down that much current, I think I'd smell something overheating. Third is that there's a corroded connection or a failed semiconductor in the regulator circuit. I don't think this is likely at all. My money's on the first possibility, a failed capacitor C811. Let's test. With my scope probe on the power supply output, and my arm in the way of the camera, I see that the output is dipping down from 15 volts to about 8 every half cycle of the power line. That would tend to confirm my hunch. But to be absolutely certain, I need to see the voltage at C811. First I have to find out where it is. Fortunately, the manual gives me a picture. Once again, I fail to get the camera angle right, but find that the capacitor is indeed not holding its charge through the power line cycle. Every half cycle, its output voltage is falling from about 28 volts to 8. Encouragingly, though, it's not completely open or shorted. It might be possible to reform it. Tektronix was smart enough to mount it upside down, so the case seals are not likely to have leaked.
But that's about all I have time for in this episode. Trying to reform that Crap-acitor, or finding a replacement, we'll have to wait until next time. I'm a little disappointed with the progress I've made, but sometimes troubleshooting is like that. So next time, the first task is working out more of the teardown to get that bad cap out of there and onto a benchtop supply to try to reform it. If you liked this episode, perhaps you'd also like to tell the YouTube algorithm that you want to be notified when I do that? Until then, stay safe, stay healthy, stay curious, and take care of one another. Bye.